Circles and trigonometric functions. Our first objective is going to be to find the 6 trig functions for a point in the plane. So given the point xy on the terminal side of a standard angle theta, like we have pictured here, there's the standard angle theta, and the terminal side is here, and you see the point xy on that terminal side. A right triangle can be created for which one leg corresponds to the x value of the ordered pair and the other leg corresponds to the y value of the ordered pair. So that right triangle would look like this green right triangle here. Notice that the base of the right triangle is the x value, is that distance from the origin horizontally, and the y value is the height of the triangle. So if I wanted to find the length of the hypotenuse, I could use the Pythagorean theorem, and I would get that length of the hypotenuse, I'll call it r, is equal to the square root of x squared plus y squared. That's using the Pythagorean theorem. The 6 trig functions of the angle theta can be defined this way. First, the sine of theta is the opposite over the hypotenuse. So that means that the sine of theta is y over r. The cosine of theta is the adjacent over the hypotenuse. So the cosine of theta is x over r. The tangent of theta is the opposite over the adjacent. So that's y over x. And then we find the reciprocals. So the reciprocal of the sine is the cosecant. The reciprocal of y over r is r over y. So the cosecant of theta is r over y. The secant is the reciprocal of the cosine. So the secant of theta is r over x. And the cotangent is the reciprocal of the tangent. So the tangent of theta is x over y. All right, let's go ahead and look at an example. So I have the point -6, 2 on the terminal side of the standard angle theta. We're going to find the exact values of the 6 trig functions of the angle theta. So here's the angle theta, and I see that the terminal side contains the point -6, 2. I'm going to go ahead and make that right triangle. The adjacent side in this right triangle is -6, which is the x value, and the opposite side in this right triangle is 2, which is the y value. And we're going to go ahead and find the 6 trig functions. Well, first, we actually need to find the hypotenuse of this right triangle. So we're going to use the Pythagorean theorem to find the hypotenuse of this right triangle. The Pythagorean theorem would say that r is equal to the square root of x squared plus y squared. So x is -6, so I get -6 squared, and y is 2, so I get 2 squared. So r is the square root of -6 squared plus 2 squared, and that means that r is equal to the square root of 36 plus 4. So we have the square root of 36 plus 4, that's the value of r, and 36 plus 4 is 40, so r is the square root of 40. And we can simplify this by factoring it into the square root of 4 times the square root of 10. And we know that the square root of 4 is just 2. So the radius of this right triangle is 2 square roots of 10. And now I can use this information to find the sine. The sine would be the opposite, which is 2, over the hypotenuse, which is 2 square roots of 10. So we get 2 over 2 square roots of 10. We can cancel out those 2's to get 1 over the square root of 10. And then we need to rationalize the denominator. So to rationalize, I multiply the top and bottom by the square root of 10. So I get, this is the square root of 10 over 10. And that is the sine of the angle theta, whatever that angle is. Let's find the cosine of theta. Well, the cosine of theta is adjacent over hypotenuse. So that's -6 over 2 square roots of 10. We can simplify that to -3 over the square root of 10. And then we rationalize that denominator by multiplying the top and bottom by the square root of 10. We get -3 square roots of 10 over 10. Now we're going to find the tangent of theta. Well, the tangent of theta is the opposite 2 over the adjacent -6. And then we can reduce that fraction to negative 1/3. So there we found the sine, cosine, and tangent. Now let's find their reciprocals. The reciprocal of the sine is the cosecant, and the cosecant then is just the square root of 10 over 1. That's it. The reciprocal of the cosine is the secant. So the reciprocal of secant is just going to be negative square root of 10 over 3. That's it. And the reciprocal of tangent is cotangent. The reciprocal of negative 1/3 is negative 3. So there I have all 6 trig functions for this point on the terminal side of an angle. All right, let's go ahead and try to find out what that angle is. So that's the next question here. The next objective is find the measure of an angle given a point on its terminal side. And here I have a point on the terminal side. It's the same point, same angle. We need to find the angle theta on the interval from 0 to 360. So we basically need to find an angle theta that's a positive angle less than 360 degrees. If you recall from the last slide, the tangent of theta was 2 over negative 6, or y over x, and when we reduced it, we got negative 1/3. Since the tangent of theta is equal to negative 1/3, we can find theta by using the inverse of the tangent, or the arctangent. So that means that theta is the arctangent of negative 1/3, and we can use this to find theta. If you find the arctangent of negative 1/3 on a calculator and you're in degree mode, you will get that you're going to have an angle that's either in the first quadrant, or you're going to have a negative angle in the fourth quadrant, because the arctangent cannot give you an angle in the second or third quadrant. It only gives angles in the first quadrant, and if it's going to give you an angle in the fourth quadrant, it's going to give you a negative angle. So when we type this into our calculator in degree mode, we get the negative angle, negative 18.435 degrees. Well, that's not the angle we're looking for, because in fact, there are 2 angles that have a tangent of negative 1/3. If you think about it, the tangent of theta equaling negative 1/3 could be because the y value is 2 and the x value is negative 6, or it could be because the y value is negative 2 and the x value is positive 6. So that would look like this. You have x positive 6, y negative 2, and that's the angle it's actually giving me. Both of these angles, this negative angle and the angle I'm looking for, have the same tangent. But because the angle I'm looking for is in the second quadrant, I know I have to modify the answer that the calculator is giving me. How do I modify it? Well, you'll notice that those angles are on the same straight line. They're 180 degrees off from each other. So all I have to do to the angle the calculator gave me is add 180 degrees. So I take this angle and I add to it 180 degrees. And the final answer then is that the angle theta that I'm looking for is 161.565 degrees. And there I found the angle theta that has negative 6,2 on its terminal side. Let's take a look at an angle in the third quadrant. So let's look at this angle here. Let's switch down to the third quadrant. So instead of negative 6, positive 2, I'm now looking at the terminal side containing the point negative 6, negative 2. All right, so negative 6, negative 2, we're going to do the same thing. In this case, the tangent of theta would be negative 2, the y value, over negative 6, the x value, which reduces to positive 1/3. And I'm still going to use the arctangent function to find the actual angle. So the arctangent is what I'm going to use. But the arctangent, remember, cannot give me an angle in the third quadrant. As a matter of fact, this angle that the arctangent is giving me is actually in the first quadrant, 18 degrees. So what I have to do, I have to think about the fact that not only can negative 2 and negative 6 give me a tangent of 1/3, but also positive 2 and positive 6 can give me a tangent of 1/3. So I'm looking for an angle who has the point with x as 6 and y as 2 on its terminal side. That would be this angle right here with 6, 2 on its terminal side. That's the angle that the calculator is giving me, 18.435. But the angle I'm looking for is on a straight line in the third quadrant across from the angle I'm given. So in order to get to that angle, I just have to add a straight line angle 180 degrees. So 18.435 plus 180 gives me 198.435. And that's the angle theta that I'm looking for. So if you have an angle in the second or third quadrant and you're using the arctangent to find that angle, you're going to have to add 180 degrees to the angle. Let's take a look at an angle in the fourth quadrant. If we have an angle over here in the fourth quadrant, this angle theta, well, the issue here isn't that the arctangent can't give me the angle. The arctangent can give me the angle, it just can't give me the angle on the interval from 0 to 360, because for angles in the fourth quadrant, the arctangent always gives you a negative. So let's go ahead and look at it. We're going to do the tangent of negative 2 over 6. So the tangent of negative 2 over 6 is the tangent of negative 1/3. The angle we're looking for, we can find it by taking the arctangent of negative 1/3. When we do that, we get the angle negative 18.435. We've already done that. We know that that's this angle here. The difference between this one and the previous two examples is this is the actual angle we're looking for. We just want it to be positive, so we need a coterminal angle. So basically all I have to do here is add one full revolution, or 360 degrees. So I start at the terminal side here of the negative angle. I add 360 degrees. It brings me right back around, but now it gives me a positive angle. So all I have to do is take that angle I got and add 360 to it. So for angles in the fourth quadrant, we actually have to add 360 once we get the arctangent. This gives me 341.565. And that would be the end of our video.